Okay, welcome. So what I have here is an equation that's in the form of y equals ax squared minus c. Now, whenever we have an equation that's in the form of ax squared minus c, we always want to look for, is this a difference of two squares? And if you notice, you might say, well, where's the b? Well, the b in this case, ax squared, has a 0 in front of it. So we don't include it, right? And you're not going to see a 0 because a 0 times any number for b is going to be 0. So we just leave it as ax squared minus c. But I just want to let you know that this is going to be your form where a is a real number, x is your variable, and c is our constant. So whenever we have that x squared or ax squared minus c, always look for a difference of two squares. So how are we going to factor a difference of squares, or how does that write? Well, there's a couple ways that we can write this. And if you want to look at just a general form, I'll show this to you. A lot of times, difference of two squares is explained like this. If I have two terms, a squared minus b squared, therefore, this can be written as a plus b times a minus b. Now, you might say, well, this is a squared and b squared. We have the x squared, but why is this c, not squared? Well, remember, for this to be a difference of two squares, this c has to be a squared number. And remember, all these squared numbers we can rewrite as a squared number, right? 64 I can rewrite as 8 squared. 121 I can rewrite as 11 squared. 9 I can rewrite as 3 squared. So if my c is a squared number and I have another squared number and I'm subtracting the two, then it's possible that it's going to be a difference of two squares. So that's exactly what we're going to be looking at when we want to solve a difference of two squares. We're going to be looking for making sure we have an x squared, and then also making sure that our c is a perfect square. And if it is then that case, then simply all we need to do is rewrite it as a plus b times a minus b. In this case would be equals 0, and then you could solve by applying the zero product property. So I'm going to go through some examples and kind of show you how this would apply to some actual real numbers. Thanks.